Hi. Do you know how to do this kind of problem? We did this in class, and you did this for your lab, except in your lab you didn't get percents. Now, when they ask for the empirical formula where they have percents, just consider it grams. It's the same thing. Why is the same thing? It's because you could say that you have 100 grams of the compound. 26.68% of 100 grams is 26.68 grams. 2.24% of 100 grams is 2.24 grams. 71.08% of 100 grams is 71.08. You could pretend that you have whatever mass of the compound you want. You could say you have 1 gram, you could say you have 5 grams, but it's just easiest to imagine that you have 100 grams. Once you decide that it's 100 grams, then you just write 26.68 grams of carbon, and you change that into moles. How do you change 26.68 grams of carbon into moles? Well, you need to get rid of the grams of carbon, like that. And in 1 mole, there are 12.0107 grams of carbon. How do I know 12.0107? I know because of this. 12.0107, right? You remember that? Okay. So now, let us proceed. 26.68 divided by 12.0107. So I got 2.221. Now it's important, it is not 2. It is not 2.2. It is not 2.22. It is 2.221 because this has 4 significant figures. This is moles of carbon. Okay? We'll do the same thing for hydrogen. 2.24 grams of hydrogen. 1 mole of hydrogen has 1.00794 grams of hydrogen. Okay, and that means 2.24. Okay, that means 2.222. 2.222 moles of hydrogen. Now we'll do the same thing for 71.08 and oxygen. 71.08 grams of oxygen. 1 mole of oxygen. 15.9994 grams of oxygen in 1 mole of oxygen. So, what we are saying is 4.443. 443 moles of oxygen. Oops! Look at this. 4 significant figures. That is illegal. Sorry about that. Messed up. There are only 3 significant figures here. It's very important to have the right significant figures. I'll show you why in a moment. So now you've converted everything to moles. Now what do? Well, you write the empirical formula. CHO. Now there are 2.221 moles of C. There are 2.22 moles of H. There are 4.443 moles of O. But you can't just have decimals there. Usually, the formula has to be all in whole numbers. Now, there are some exceptions, but not in our class. The exceptions arise when you study minerals and advanced inorganic chemistry at a university, not at our college level. So anyways, divide by the lowest. Divide by the lowest. This is the lowest. Okay. And now, let's find the answers. 2.221 divided by 2.22. You see that? That is why it is necessary to be careful with the significant figures. You need to have an answer here that is a whole number within 0.01. This is a whole number within 0.00045. So this is good. This is just C1. H, well, of course, 2.22 divided by 2.22, they cancel out. This is just 1. And the O, see, it's important to have all these significant figures in the 4.443 and 2.22 because, look, this is almost a whole number. It is within 0.001. As long as you are within 0.01 of a whole number, you're good to round. Okay? So this is just a 2. So the empirical formula is CH SiO2. Does that make sense? Send me email if that doesn't make sense. Thanks.